Hi guys. So in this video, I will be explaining you about how will you create your own custom linked list. Okay. So in the last video, we have discussed about how can you create your own custom array list. If you haven't gone through the video, please go through the link which I'm giving you here in the cards. There you will first understand how can you create your own custom array list, which are most frequently asked in interviews. Okay. So in this video, we will be focusing more upon how can you create your own custom linked list methods. Okay. So there are various methods present in linked list, right? Methods like add at a specified position, only add with position, add first, add last. Okay. Remove first, remove last, and then contains method. Contains is basically we are searching for that element within that linked list. Okay. So if that is found, it will return be true, or else it will be false. So these are some of the basic operations that we generally do with linked list. Okay. And how can we mimic that by writing our own custom linked list? So let's understand that step by step. So first of all, let's understand how does linked list look like. Okay. So what is a linked list? So if you observe over here, linked list is nothing but it's a group of nodes. Okay. So this will be one of the node. Okay. Node which contains the data. Okay. So node will contain what? This is one of the node. Okay. So node will contain data. Okay. Node will contain data and it will contain the next node's address. Okay. So this is only one of the node which I can consider. Okay. This is one node. Okay. So one node will contain the data for that particular node, and then it will be containing the address of the next node. Okay. So then again, it will be like a next node. So this is node 2. Okay. Then this is node 3. Okay. Like that, it will be keep on there, keep on coming. Okay. The linked list format. But the data will not be stored in the contiguous memory location like one after another in the indexing format. It is getting stored in array list in indexing format. But for showing you for understanding purpose, I have shown you like this. But normally it is being stored at any position. So that can be that values can be get with the help of address. Okay. So n1 we are showing you that it is storing at first place. So n1 can be here also. Okay, n2 can be here also. So basically n5 can be here. Okay, n2 can be here. Okay, so like this in the space, if you consider there are a lot of nodes or a lot of balls which are revolving around the space. Okay, you are not knowing like which ball will point to which particular ball. You don't know, right? So similarly, you can understand with linked list as well. There are various nodes which are revolving around in the space, and which ball will hit which ball is connected to which ball. You don't know. So how can we understand like which one is connected to which nodes? So that connection we can establish with the help of address. So address is nothing but a memory location which is pointed to that particular node, if to which the previous node is getting connected to. Okay, so let's suppose here there are a lot of nodes which are revolving around in the space. Okay, so in that scenario, what will happen? So let's suppose this is node 5 or node 3. Okay, this is node 1. Okay, and this is node 6. So node 5 is somewhere around here and node 6 is somewhere around here. So how these two will be connected? So node 5 will be having data and next node's address. Okay, so next node's address will be pointing to here. Okay, and then node 5 will be having data which is particular to that particular node only. And node 6, if it is a doubly linked list, so internal data structure, if it is doubly linked list, then from node 6 also it will be pointing back to node 5. Okay, so if we are going reverse, so node 6 next will point to node 5. Okay, and node 6 next, let's suppose node 7 is somewhere around here. Node 7 is somewhere around here. Okay, and node 7 is containing me what? Data and next node's address. That means node 8. Okay, so what will happen? Node 6 next will point to node 7. Okay, and where is node 5? So here is node 5. So node 5's next is pointing to node 6 and node 6 next is pointing to node 7. Like that only each and every nodes in space will be connected with each other via memory location. Okay, so it is not index based, rather it's a memory based. So that is the simple thing that I wanted to tell to you. So now let's understand. Okay, the next thing is how can we create our own methods present in the linked list. Okay, so let's understand that again. So now let's understand how, what are the methods and how can we create our own custom methods in it. So first of all, what are the methods that we generally use with linked list? Okay, there are multiple blocks containing nodes data, okay, and the next node's address. Okay, so what all things it will be there? First method will be add first. Okay, I want to add something at the first node. So first what happens, head is pointed, right? Head is pointed to the first node. Basically in normal linked list, what happens, head is pointing to the first node, and first method will be add first. Okay, so add first method will be there, which will add any element in the first. Then add last. Okay, add last is also one of the method which adds element at the last. Then add at a specified position. Okay, we will be passing position over here, and then it will add me at any position. Okay, it can be 1, it can be 2, it can be 3, any position. Then similarly, there are three methods for remove as well. Remove first, remove last, and remove at a specified position. Okay, then contains method which will see that whether the element is present within that linked list or not. Okay, and at the end we can write our own display method to display all the elements of the linked list. So like that we can mimic the implementation of the actual linked list. Okay, so let's understand like how can we implement these methods. Okay, so first of all, let's understand add first. So add first, what will happen, we are generally adding an element at the first. So what we have to do in this scenario, we don't have to do anything much. Okay, just we have to point the head to the new node. Okay, so whatever node we are adding at the first, so initially there were no node at first, head was pointing to first node. So how can we create a new node, our own first node? For that, just we have to point head to that first node. That's it. Automatically that new node will create a connection to the first node. Okay, so like that we have to do for add first. And similarly for remove first, we have to write some edge cases also, like if head is not present, okay, if linked list is empty. So those kind of scenarios we have to write at first for edge case scenarios to handle, or else if there is no edge case scenarios, then we can directly write it, we can directly point head to the first node, which is a new node basically. Okay, this is adding at first. Then removing at first. So basically what will happen, you want to remove this. Okay, we want to remove this first node. What to do in that scenario, we have to point head to the next. That means head will point to head's next. Simply one change you have to do and will remove the first node. So basically in Java, everything is garbage collected. Okay, so if the element is present in the heap memory and no other nodes are pointing to that particular node, then automatically after a cycle, garbage collector will come and look like whether is there any nodes pointing to that particular memory location or not. So if there is no nodes pointing to that memory location, then automatically garbage collector will clear that node. Okay, so that is the important feature of functionality which is present inbuilt in Java. Okay, so that is the thing with add first and remove first. Then comes add last. Okay, so what will happen in add last, we are basically adding new node in the case of add last. Okay, so here if you observe, we are adding new node at last. Okay, and the last node should point to this new node. So this is the thing that we have to implement over here. So basically head is pointing to first, okay, and nothing is pointing to last. So we have to reach till here, right? Then only we can do any kind of operation. So what to do in that scenario? First, we have to run a loop. Okay, starting from head, we have to we can't directly allow head to reach the last, or else nobody will be pointing to first. Okay, so if nobody is pointing to first, then what will happen? Garbage collector will remove that first node. Okay, then what's the point of creating linked list? We know, right? It is not index based, so garbage collector will keep on coming cyclically to see like if there is any node pointing to that any nodes over here. If there are no nodes pointing to these nodes, then automatically garbage collector will remove them. So I need to keep head at first position so that garbage collector will get information like, yes, head is pointing to first node. Okay, so what we have to do, we have to create current node or temp node. Any node you can create and you can point it to head. Okay, so basically current node is nothing, it is mimicking head node. Okay, this is a thing. And current node will iterate and will reach till here. Current node now will iterate and will reach at the last node. Okay, and as soon as it reaches last node, what will I do in that? We have to point current nodes next to the new node. Okay, so previously the last node, or where the current node is currently present now, it was pointing to null. So instead of pointing the last node to null, we have to point that last node to the new node. Okay, simply this change we have to do. Whatever current node or the last node is being pointed to, we have to point it to a specific new node which is coming now. Okay, this is with add first, and for delete add last, sorry, and then for delete last we have to remove this particular. Okay, so what we have to do in that scenario? So previously we have to create one current pointer which was pointing to head to reach till here. Okay, and then we have to point it to these positions, these pointers next to null. Okay, and then this particular node next will be pointing to null. Okay, so what we have to do? Nothing. This particular second last nodes next should point to null. That's the important thing. And once this node is pointing to null, then automatically garbage collector will remove the last node. Okay, so this is very much simple. Just we have to understand it like how everything is linked in space. Okay, so we understood add first, add last, remove first, remove last. So don't worry, we will be showing you code also like how these things are working internally. Then you can grab the best part of it. Okay, so now let's understand fourth important method, which is nothing but search in that linked list. So search is nothing. There is no method like search in linked list class. So mimicking that functionality, it is contains method. Okay, so similarly in array list there is contains method. Similar to that, linked list also contains method. Okay, so contains method will do what? Contains method will allow one parameter. Okay, in that parameter it will have the element. Okay, so that particular element node, okay, will be there, or it will be having data. So what will happen? We have to iterate the entire linked list. Okay, and we have to iterate entire linked list, and we have to keep on comparing the data of the node with a given element. Okay, so if any node's data is matching with this element, we have to return true. Okay, and if we have went till the last and we didn't find any node data pointing to this element or equal to this element, then we will be returning false. It's simple like that. Okay, so these are basic 5 methods which are present in linked list, which are most commonly asked in interviews. Okay, so now let's understand through code like how these things that we have discussed about is actually worked in the backend. Okay, so now let's understand my Eclipse so to show you the code snippet. Yeah, I hope you can see my screen now. So if you observe over here, I've created my new node. Okay, this is my node. Okay, any node which you can create of your choice. So you don't want to use the existing functionalities of linked list. Okay, you want to create your own custom linked list. So for that, everything you have to create by yourself. Okay, whatever nodes present in that linked list, whatever data that it can handle, so those things we have to implement it by our own self. Okay, so what we have to do in that scenario, we are creating my own node. Okay, and node will contain what? Node will contain data and the next node's address. So those things we are storing in it here, and then we are creating the constructor. Okay, so let's suppose we are making use of this class, and then in that class we are initializing with the node and the next node's address. So those data we have to initialize it via constructors. For that we are making use of constructor over here. Then we are creating our own custom linked list implementation class. Okay, so in a normal public class we can have n number of normal classes. So this class is basically a normal custom linked list main class which contains 2 classes. First class contains my node containing data and next node address. Then custom linked list implementation class where we are implementing all the functionalities of linked list, okay, which are of use. So here, first of all, what will happen in a particular linked list? There will be some head. Okay, head will pointing to first node location. Okay, then it will keep on iterating for further use. Okay, then we have to create a constructor for custom linked list implementation where head is pointing to null, because initially there is no element present in the linked list. So if no elements are present in the linked list, then head will pointing to null. Okay, I hope you got this concept. Then the next concept is insertion at the beginning. So that means add first. Insertion at the beginning is nothing but we are adding any element at the first position. So we are passing data. So which data you want to add at first position. Okay, so we are creating new node because we have to add a new node in a linked list. So that's why we are creating new nodes object over here and passing data. Then that new nodes next should point to the head. So currently head was pointing to the first node. Okay, so whatever new node we are creating over here, that new nodes next should point to head, and head will now point to that new node. It's very simple, right? New nodes next, whatever new node is coming over here. So let me show you here so that you will get the best idea of it. So if you observe here, okay, so this is linked list with multiple nodes. Okay, so now new node is coming over here. So now new nodes next should point to head. So initially, like, head is here, head is here. Okay, so now new nodes next will point to head now. Okay, and head now will point to new node. So previously head was pointing to this first node. So instead of pointing to first node, now head will point to this new node, and new nodes next will point to head. Okay, so before changing the pointer of head, we have to first allow new nodes next to point to head location, so that it will create a connection between these two nodes. Okay, I hope you got the clarity for this. So this was adding first element into the linked list, then adding last. Okay, so we are adding any data at the last of the linked list. So what we have to do in that scenario, we are adding the node into that list, right? So that's why we have to create a new node. Okay, and then we are checking. This is the edge case scenario that we have to check basically. So if head is null, head will point to new node. Okay, if head is null, then head will point to that new node. That means one node only is present. Previously, there were no nodes. This is basically the edge cases that we have to handle. Then I already told you, right? Whenever we have to add any element at the last, there are no any specific pointer which is already pointing to last node. For that, we have to create our own current node or temporary node pointing to head, and we should not remove the head pointer. If we remove head pointer, then garbage collector will remove the first node. Okay, and all the linked lists will get disrupted because everything is connected with first node. Okay, in space also everything is connected via first node only. First node's next is pointing to second, second node's next is pointing to third somewhere. Okay, so head should not be removed from its position. Okay, so we have to mimic the functionalities of the head pointer. So for that we are making use of current node pointing to head node, and then current node will move or iterate through the entire linked list till the last. Okay, that only we are doing over here. So my node's current is pointing to head, and then current dot next will move till its next is pointing to null. Till that point of time, we are iterating current. Okay, and as soon as it reaches the last position, then currents dot next, instead of pointing it to null, we have to point it to new node. Okay, and then new nodes next will be pointing to null. So previously, what was happening? The current node's location, what was there, the current node is pointing to last now after this. So that's positions next was null before. Okay, so now what we are doing, we have to add the new node, right? So currents next will point to the new node, and new nodes next will point to null. Okay, I hope you got a clarity on this. Then adding at a specified position. So we need data, and we need at what position you want to add that particular data. Okay, so this is basically adding node at a specified position, in the middle, in the first, in the second, in the third position, anywhere it can be. Okay, so there are a lot of scenarios that we have to handle over here. So it can be like insertion at a first that we already done before. Okay, so those things also we have to handle. So we are checking over here the edge case, like if head is null, then head will point to new node only. Okay, if position is less than 0, let's suppose user is doing some mistakes. Users are adding like position as -2 or -5. So if that is the scenario that we have, then we have to return directly like position can't be less than 0. Okay, position can't be less than 0. Okay, then insertion at the beginning, that also can be happening, right? So if position is 0, that means we have to add at first. So we have already written one method to add element at a first, right? So that only we can call and add any element at a first location. That we can add it over here. Then we are creating our own custom current node, and we are pointing to head so that we can iterate it and reach it, allow it to reach till the last. Okay, and we have to maintain pointer also. We have to see that at what point, what is the position at which it is pointing when it reaches to the position which is given to the parameter. So if you see over here, in the parameter we have been given position. So we have to insert at that particular position only. So we have allowed current to reach till the last to handle the worst case scenario. So let's suppose position is given at the last. Let's suppose last node's position is given to us. So we have to iterate till the last only, right? So for that, we are iterating current node till the end location. Okay. So while current is not equal to null and at pointer. So initially pointer is pointing to 0. Okay, nothing it is pointing to. So we have to run the loop till pointer is less than position minus 1. Okay, so what is happening over here? So if you see, 1 second. Yeah, so if you see over here, so let's suppose there are multiple nodes over here, right? There are multiple nodes over here. So what will happen? Let's suppose you want to insert at any position. Let's suppose 0, yeah, 1, 2, 3. Let's suppose you want to insert at third location. Okay. So what we have to do? The pointer will first be at 0th location. Okay. So pointer will be pointing to this location now 1. Then is 1 is less than 3 minus 1 2? Yes, it is there. Okay. So it will move ahead. Okay. Now pointer is pointing to 2. Okay, so is 2 is less than 3 minus 1 2? 2 is less than 2? No, condition is not satisfied. So it will come out of the loop. Okay, and then it will pointer will still point to this location only, first position only. Okay, and current will come till here because current's next this current flow is also dependent upon this pointer only. So now current will pointing to this node only, which is the first node. Okay, so this can be the edge case we have to handle. If current equal to null, then position is out of range, it is not presented within this. Or else if current is not null, then in that scenario this new node's next will point to current's next. Okay, so this element we have to insert basically. Okay, so current was keep on getting moved. Okay, so as soon as it was at this position, so current will point to current next. So now current will be not pointing here, now current will be pointing here. Why? Because when it was at this particular position, first was while current not equal to null, so current was not null before and pointer was 0. So 0 was less than 2. So first was this 0 was less than 3 minus 1, which is 2. Okay, the condition was satisfied. So it will come here. Current pointer will come here now. Okay, so now the next iteration will go. Okay, so now current is at this position. Now we will see the pointer. Pointer is now increased by 1. Okay, so now the next thing is 1 is less than 2. Yes, condition is satisfied. So now current pointer will come over here and then pointer will increase with 1, which is 2. Okay, so now 2 is less than 2. Condition is satisfied? No. Okay, so it will reach till this position. Okay, now if current is null, then position is out of range, or else new nodes next. That means whatever next new node we are adding over here, this is the new node which is adding over here. So new nodes next will point to this current nodes next. So this is the current node, right? So this current nodes is pointing to this particular node as of now. Okay, so new nodes next will point to current nodes next, and current nodes next will point to new node now. So previously current nodes next was pointing to here, right? This particular node. So now we have to remove this pointer and we have to allow the current nodes next to point to the new node. And before doing that, we have to connect new nodes next to the current node. Okay, so this is the flow that we have to understand. We have to go it in a reverse fashion. We have to let this new nodes next to point to current nodes next, so that it will create a connection between the existing linked list. Okay, and then current nodes next will point to this new node. Okay, so that new node so that this current node's next wala node should not get removed by garbage collector. There should be some node pointing to this current node's next node. Okay, so if we directly remove this pointer first, then garbage collector will come and they can remove this node, right? So to remove that possibility, we are first allowing this new nodes next to point to this current nodes next. I hope you got the connection between them. Okay, so like that only it will work over here. Okay, so I hope you understand like how you can add any node at any given position. Yeah, so now let's understand removing any element from any position. Okay, so first is removing first element. If we want to remove the first element, first we have to check whether head is null or not. There can be a scenario that There is no element present in a linked list. So that also we have to handle that. So if head is pointing to null, that means there is no single node also present in the linked list. So we have to write no data to delete. Okay. So if that is not the case, we have to point head to the next node. So if head is pointing to the next node, then automatically this particular first node, no node is pointing to this first node. So what will happen? You already know. Okay. So now remove last. Okay. So remove last, what will happen? We have to iterate it till the end. Whatever we have done while doing the insertion, the same thing we have to do it over here. We have to let current node, which is mimicking head node, to reach till the last. Okay. And once it reaches the last location, we have to uh, run a loop to reach current nodes to last, and once it reaches the last node, current nodes next will be pointed to null. Okay, so we have to remove the last, right? So what will happen? So this is one of the things that we have to understand over here. So current nodes next should be not null, and current nodes next should not be null. Okay, so we have to reach the pointer of current node to that location. So why we have taken this current nodes next should not be null, that we should understand now. Okay, so let's understand that particular flow. The color is very much vibrant, so it will be good to show you. Okay, so let's suppose there are 6 nodes present in the linked list. Okay, so head is now initially pointing to the first node. Okay, and current node will mimic head node. Okay, so now current node will move, it will iterate for the entire linked list, and it will reach till last. And once it reaches the last, will it be able to reach the last node? Let's understand that. So what is the condition to break this while loop? While current nodes next is null, it's correct. Then current nodes next should also be not null. Okay, current dot next should not be null, and current nodes next should also be not null. Okay, so this is satisfied over here. This is not null. This is satisfied over here. This is not null. So once it reaches over here, then current nodes next is this. Current nodes next is null. No, but current nodes next is null. So this will not satisfy over here, but it will satisfy at this particular location. Okay, so once current node has come this particular location, then what will happen? Once it reaches to this particular location, then current nodes next is pointing to null. This is correct. In current nodes next is also not null. This is also correct. So current node now will point to this particular location, not this location. It can't come at this location once this while loop condition is written. Okay, so now once it reaches over here, what will happen? Current node is pointing to current nodes next. Okay, so once current nodes reaches over here, current node will come over here. So finally, current node is pointing to the last second position here. Okay, so now what will happen? Once current node has reached over here, then current nodes next will be null. So now current nodes next will be null. So what will happen if current nodes next, like this nodes next is null, then automatically this particular node, which was the last node, will automatically get removed by garbage collector because there is no pointer pointing to this last node. I hope you got the clarity on this. And this way we can remove the last node from the linked list. Okay, I hope you got this concept, like how we can remove any node from the last. So we understood add first, add last, add at specified position, remove first, remove last. Then we have to understand remove from the specified position. Okay, so let's understand that. Yeah, so removing any element at a specified position. So we are checking if position is less than 0, that means it can't be less than 0. So the same scenarios that we have already written, those things only we have to write it over here. Okay, if position is 0, that means we have to remove from the first position. So for that, we have already written the logic of remove first. It will process that. Or else we have to write a normal delete at any location. So pointer will first point to 0, then current node will mimic the head node. Okay, and we have to write while loop to check while current is not equal to null and pointer is less than position -1, the same way which we did for adding at any location. Okay, then current will point to currents next and pointer ++. Okay, so if current is null and currents next is also null, so in that scenario, position will be out of range. Okay, it will not be possible to remove from that particular position. Okay, because currents next is null. So how can we remove that? So position is coming out of range. Okay, so these are connected with each other. So don't directly focus like current is one node, current dot next is null. So that is not the case. We have to link it with this particular loop. So while current is not equal to null and pointer is less than position minus one, till that point of time, we have to allow current to move ahead. Okay, and once it reaches to that particular position, then currents next will point to currents next. Okay, so what will happen in that location? So let me show you once. So this is one of the linked list containing nodes. Okay, so let's suppose you want to delete this particular node. Okay, this is 1 2 3 4. You want to delete this particular location node. Okay, so what will happen now? It will keep on iterating. Current node will keep on iterating. So first of all, position of pointer was 0. First of all, pointer was at 0th location. So now 0 is less than which location? 4. 4 minus 1, which is 3. 0 less than 3, condition is satisfied. Current will be here. Then pointer will be increased by 1. Okay, so 1 less than 3, condition is satisfied. Current will move over here. Okay, now 2 less than 3, condition is satisfied. Now current will come over here. So now 3 less than 3, condition is not satisfied. So it was not satisfied before, so current will point to here. So current is now pointing to this location. So now we have to remove this particular node. Okay, so what will I do in that scenario? So currents next. So previously current next was pointing to this node. So instead of pointing currents next to this node, what will I do over here? Instead of pointing current nodes to this particular node, we will point current nodes next to this particular node. Okay, so now current nodes next will directly point to this. Okay, so this middle element will be gone. Okay, so everything in linked list is all about pointers, like which node is pointing to which node. Everything is linked with that only. So if there is no element pointing to this any node, then garbage collector will remove it automatically. Okay, so we don't have to think about the removal of that node. Okay, so once this particular node is gone, then this current node's next will point to this node. Okay, automatically this node will be gone. This middle 4 wala node will be gone automatically. Okay, because there is no other pointer. So like this, we can remove node at any location from the linked list. I hope you got the clarity of that. Yeah. So let's understand contains method. Okay, contains is basically searching the node or data in that particular linked list. Okay, so initially current is pointing to head location that we do in every scenario. While current is not equal to null, we have to iterate. Basically, we have to search for that data in the entire linked list. So current node's data, we have to see whether it's equal to the existing data which is passed over here or not. So in the entire linked list, it will keep on searching. Okay, and once it's matched, then it will return me true. That means yes, this data is already present in the linked list, or else it will keep on moving ahead. Current will point to current next. Okay, so if it is not found till it reaches the last node, it will return me false. It's as simple as that. When searching the node in a linked list. Okay, so this is the way we can see the contains method. It's basically equivalent to search method. And then there's a display method where we are displaying the elements of the linked list after every operation. Okay, so if head is null, list is empty. Then current is not equal to null, then current will move to current next. Current data will be printed over here, and then at last we are adding null. Okay, once it reaches the last node, after that the last node's next should be pointing to null. So for mimicking that, we are writing null over here, because automatically next node will not point to null, right, once it reaches last. So this is the thing that we have implemented with logic purpose. So now let's understand with some examples like how this is working. Okay, so let's suppose some example I've taken, like custom linked list object I've created. This is this class only. Okay, then we are adding first. So 10 is added at a first. Okay, so it will create a node over here. Okay, so it will, what it will do, it will basically create one node over here. Okay, so new node is added over here. Okay, new node is added over here. This is the node containing two things, which is 10 and next node's address. Okay, so next node address will be null as of now because only one element is added over here. Okay, so now it will move ahead. So first we have added node at the first location, then add last. Okay, so we have added a node at the last location. Let's suppose it's 20. Okay, so initially was 10. Then add last 30. Okay, so it will again add the new node at the last with 30. Okay, then add 25 at a second position. Okay, so this is the second position basically, so it will add 25 to it over here. Okay, it will point to this particular node currently. Okay, and it will be connected like this. Okay, and add first 5. So now 5 will be added at first node. So now how is the memory location allocation is happening over here? 5 is pointing to 10, 10 is pointing to 25. Okay, and then 25 is pointing to 20 and 20 is pointing to 30. So this is the memory allocation which is happening internally inside the linked list. Okay, so this is the thing that is happening over here. So now let's go down. So if we display, if we call the display method what we have written over here, over there at the top, okay, to display all the elements of the linked list. So now similarly you can do it for rest of them. Okay, so you can remove first also. If we remove the first position, 5 will be removed, so 10, 20, 25, 30 will be printed over there. Okay, remove last. If we remove 30, then 10, 20, 25 will be printed over there. And then remove 1, so first element data will be removed. Okay, so 20 will be removed over here. Okay, so basically it is considering the 0 based pointing. Okay, so first position is considered as 0. Okay, so like that we have to move ahead. Okay, so remove 1 means it is removing 20, it is not removing 10. That means what? It is 0 based indexed. Just like in arrays it is there, right? 0 based, 1 based indexing. So in linked list also it will be like a 0 based indexing. So if we are passing 1 over here, so it will remove the second element from the linked list. Okay, because second element is pointing at first index. Okay, and this one is at 0th index. So like that we have to imagine. So we have to remove the next index, second index basically. Okay, and like this it will check whether list contains 25 or not. Yes, the final list is this, it contains 25. And is it containing 30? No, 30 has been removed. Okay, it is not present in the linked list now. So let's run it and see the output. Yeah, so if you see over here, the data is printed as we have discussed. Okay, and always remember this one was 0 based indexing. Okay, so first element will be 0, second element will be 1. So like that the code has been written. Okay, and we can modify it as per your own need. If you want first node to consider as first pointer, then we can write accordingly. Okay, so yeah, you can modernize it, you can write it as per your own wish. So it is customized basically. So the interviewer may tell you to make some changes into it, so you can make change and you can do it accordingly to yourself. Okay, to understand as per your understanding. So like this we can implement our own custom linked list. I hope you got a clarity on how you can create your own custom linked list. So in the next video, we'll be creating our own custom hash set. Okay, so be prepared for that for your next upcoming interview question series. Okay, so till then, it's Devjit Roy. We'll be seeing you in the next video. Bye-bye. Everybody, I provide consultation calls or one-on-one session calls or one-on-one mock interview sessions for all of you so that you can ace ahead in your IT interviews, okay, and crack the big service based or big product based organization. So how can you do that? So I am taking mock interview sessions, so you can go ahead in the description box below and you can register a book a call with me, okay, one-on-one session call, and we'll be having a one-on-one conversation.